Welcome to Ask and Learn.
All right, let's go ahead and answer this question. We have the function y equals to x over x squared minus x plus 1. X is defined to be between 0 and 3 inclusive, and it's asking you what are the absolute extrema. Okay, so whenever you solve these kind of problems, there are two things you need to keep in mind. First, always check the endpoints, okay? Because the extreme value theorem basically says that if if a function has an extreme value, it will always happen at the endpoint or somewhere in between, okay? So if the endpoints are included in the analysis, we always check. So we're going to plug in 0 and 3 to figure out whether it's going to be an extrema. Okay, the second thing you want to keep in mind is to check the critical points. So we're going to look at the derivative, let it equal to 0. And if you want to be very precise, we do want to check the second derivative to see if it's going to be a local maxima or a local minima, or by observing the first derivative and check if it's actually going to change the signs, but I am going to omit that detailed process of that, okay? So I'm going to assume that when the derivative is equal to 0, it actually is a critical point rather than a saddle. Okay, so let's go through the calculation here. First, I am going to call this f and plug in 0. F of 0 is very simple. The numerator is 0. The denominator is not 0, so it'll end up being 0. Next, f of 3. A quick calculation tells you that the top is 3, the bottom is 9 minus 3, 6. 6 plus 1 is 7, so it's 3/7. So at least I know that 0 is not an absolute maximum. 7/3, probably. Okay, now let's check f prime. This is a quotient, so we can use the quotient rule. So it is going to be x prime times the denominator. Of course, x prime is 1, so you will have x squared minus x plus 1 minus the denominator prime. So it is going to be 2x minus 1 times the numerator, which is x. Now, the denominator, of course, you're going to have to square it. So I'm just going to call it triangle. And the reason is I know that I'm going to let this equal to 0. And if you observe that the denominator is an irreducible quadratic, meaning that the b squared minus 4ac is a negative number, the denominator is never going to be negative. So I don't have to worry about the case where there's a division by 0 or anything like that. So I'm going to omit it because the numerator simplifies to 1 minus x squared. And if I multiply the denominator on both sides, it disappears anyway. So I don't have to worry about that. Okay, so you can see that x is plus or minus 1, but 1 is the only number that belongs in this limit, so we know that 1 is the only point that we need to check. Let's figure out what f of 1 is equal to. The numerator is 1, and the denominator, x squared minus 1, is simply 0, so the remaining 1 makes this equal to 1. And 1 is, of course, larger than 3/7. Okay, so from this analysis, we figured out that this guy, it is going to be the local minimum, or the absolute minimum, excuse me. The bottom one here is going to be an absolute maximum. And 7/3 is just a point at the endpoint. If you use a graphing utility, you will actually see that this is a type of graph that looks something like this. And 0 to 3 is actually a region from here to there. And this is going to be 1, this is at 0, and this height right here is the 7/3 that we actually observed. And this is how you answer this problem.